students. You are welcome to session 5 of unit 6. In the previous sessions, we looked at the components of a lesson plan. In other words, what goes into a lesson plan. We have gone through all of them. We need to write one to have a feel of a lesson plan. So in this session, we are going to write a lesson plan on the chemistry topic, electron affinity. Let's look at our objectives for the session. By the end of this session, you should be able to write a lesson plan using any SHS chemistry topic. We have looked at the components of a lesson plan, or the things that go into lesson plan, and here we are going to apply them to write a lesson plan. We mentioned the institution. So for example, here we are using University Practice Senior High School. The subject is elective chemistry. Topic is electron affinity. The form is SHS2. Sometimes you would have to indicate the class also. So class may be 2 science A or the very class you are going to teach. The date, very important, and the time. So looking at this, a teacher can just pick this plan. He knows that I'm going to a class in Form 2 on this date, and then from this time to that time. Next is relevant previous knowledge. Remember, we are going to teach electron affinity. So the RPK should be related to electron affinity, or things that will help the students understand electron affinity. Students can explain the following from the previous lesson: effective nuclear charge or nuclear attraction, shielding or screening effect, atomic size, cations and anions, and then groups and periods of the periodic table. It means we are going to review these things, and we hope that they will help the students better understand the electron affinity. Okay, so what are our objectives? We have 2 objectives. By the end of the lesson, the student will be able to 1. Explain the variation of electron affinity across a period and down a group of the periodic table. Then 2. Explain why a cation has higher electron affinity than its corresponding neutral atom. So we are going to have 2 steps in this lesson. One is for this objective, and the next is for this objective. What resources do we need? You need chart of periodic table, then chart of atomic structures of the following elements: lithium, boron, fluorine, potassium, and cesium. Okay, so let's move on. Having put these things down, we need our introduction. What goes on in our introduction? The teacher introduces the lesson by reviewing the RPK of students through questioning. One thing that you should note is that for any activity of the teacher, there should be a corresponding activity of the student. So if the teacher is going to introduce the lesson by reviewing the previous knowledge of the relevant previous knowledge of students through question, what are students expected to do? Students are to listen to the questions and answer them. So that will be the activity of students. You shouldn't have a case where you have something at the teacher activity and there is nothing at the student or the learner activity. There should be something there. What should the students be doing? For any point in time, the student should be doing something in the lesson. So what are the questions? What is meant by the following terminologies? Effective nuclear charge. What response do you expect from the student? You should indicate it at the learner activity. Though it's not the learner who is doing it when you are planning, but you should anticipate. So in some cases, it is written on top here as expected response, what you expect from the student. So students are to provide the answer, and the answer is that effective nuclear charge is the net positive charge which the outermost electron feels through attraction by the nucleus. Next is shielding effect, and so here also students should provide this answer, because it's not the student who provided you with this answer to write here. They might not say something exactly as you have written here, but something that is close, or at least there are some major points that you want to see in the student's response. Alright, so we also mentioned atomic size, so you have to review it. And here also students are to provide a response to the atomic size. Next question is, what is the difference between a cation and anion? We expect these responses from the student. A cation is an atom which has lost electron or electrons. It is positively charged, whereas anion is an atom which has gained electron or electrons. It is negatively charged. So you expect these from students. They might not be able to say exact as you have written here, but at least something close is okay. Alright, we are done with the introduction. Right after introduction, we move on with the development. Remember to indicate time to any activity or any component on the lesson plan. So content development step 1 is going to take 20 minutes. So we should be guided by the time, and we should work within this time frame. Otherwise, you will have to squeeze other components or will not even touch on it at all. So we make sure to operate within 20 minutes. What is this step about? It's about definition of electron affinity and its variation across a period. So this is what is going to be the major idea, and we'll have points under, or this is what is going to be the title that we would underline, and we'll have our major ideas under this. So we come into the activities. Remember, it's not something that you're only writing this as a topic and then you continue with notes for students to write. There should be activity. What is the teacher activity under this development? Teacher now defines electron affinity. So as you are defining, what should students do? Students are to pay attention, listen, and write the definition that you are giving to the students. Electron affinity is the amount of energy released when 1 mole of an electron is added onto the outermost shell of an isolated gaseous atom or ion. These are examples. This is what you are, the activity you, the teacher, you are undertaking, and students are also to perform these activities. This is not our major idea. Alright, so you close it. Next activity is teacher discusses variation of electron affinity across a period with students. Teacher shows the atomic structures of some elements in the same period as shown below to students. So these ones are part of the materials we mentioned. And so at this point we are going to use this material. So the column for teaching learning resources, this is the time that we are going to mention this, maybe a chart of this. The students are to look attentively at the atomic structures that you are going to show to the students. When you show something to students, at least you should follow it up with questions. Teacher uses question to reason with students. What should student do? Student listen to the questions and answer them. And then look at the match over here. This one, or the student response or student activity here, rightly correspond with the teacher activity. We shouldn't have a teacher activity, let's say on this line, and the student activity is on the next line or a line above. No, they should be on the same line. They should all start on the same line. Assume you have put a rule here. Alright. What are the questions? What do you observe horizontally from lithium to fluorine from the diagrams that you show to them? Students are to provide this answer. The number of shells are the same, but proton number increases from left to right. Yeah, you are only expecting students to provide this. They may be making different observations, but try to direct their observations. So you may provide them with clues so that they don't tell you something that maybe moving as we move from left to right. Somebody can even say that the dot in the middle as we move from left to right are the same, which is not what you are looking for. Alright, so direct their thinking. Since proton number increases, so this will be a follow-up to this question. What will happen to the effective nuclear charge? Students would also provide this response. Then, what will also happen to the shielding effect? Students provide this response. Alright, so these things will go on in the teacher learner activity columns. After that, what do we take out of those activities? We have our major ideas. What are students going to take home? So at the major idea side, we write these things for them, for students to write and then take home. We will not be able to complete a whole lesson plan in this session. So we'll end it here, but then remember that we had two objectives and we have covered one. Up to the major ideas, we are done. So we are going to underline and then look at the second objective in the last session, that is the session 6, which means that we are ending the session here and you have these self-assessment questions to try your hands on. Let's meet in session 6 to continue with the lesson plan.